Hello students, my name is Manpreet Singh and we are going to discuss physics question from RENEET exam 2026, right? Let's first read the question. A cylindrical cork of uniform density floats in a liquid of density rho. If the cork is depressed slightly and released, it oscillates harmonically with time period t. So first understand the concept, okay? In this case, you may not be knowing the formula as a NEET student. So let's see how we can solve it. Now try to understand. This is our beaker. In this case, in initial situation, let's consider this is the body we are talking about. So two forces will be acting, W, and in upward direction buoyant force will be acting, right? Now that is the thing. Now they are balanced in this case, that's why it is in equilibrium right now. Now after that, if I move it slightly below, let's consider I move it slightly below by how much x. So how it will look like? Now if I move it by x, then it will reach here. Got it? It will move down by x. Got it? In this case, now again, this W is acting, this buoyant force, I am writing this one exactly here. This buoyant force is acting, but extra buoyant force will start acting. How much? This much volume. Understood? Due to this much extra, you can say the water which got displaced, the liquid which got displaced, okay, buoyant force will be acting. So this force, okay, this will be how much? Let's consider the cross section area of this cork is how much? A. Cross section area is A. It, this part, this extra volume which got occupied is x. Okay, so this extra force we are going to write down, this extra force which will act in the upward direction. I will write it F dash B. Okay, now what is F dash B in this case? F dash B is going to be this volume. It is going to be how much? A into x into how much is the density. So they are saying we will take some particular density. Now in this case, weight of the liquid displaced. So we will be taking the density of the liquid here. So A into x into rho into g. So this is the extra force acting in the upward direction. So I can write it with, let's consider the mass of this cork is m. So it will become m into A is equal to A into x into rho into g. Now acceleration will become what? All the constants I will take here, a rho g by m into x. Now we already know this becomes what? This is what? This is our square of angular frequency, that is omega square. So omega square is how much? Omega square is equal to area of cross section into g by mass of the body into density of the liquid. Okay, so now in this first case we have taken density rho 1. Okay, so in first case we have taken density. First of all, I will try to write it in terms of time. So omega will become what? Omega will be A into g into rho by m. Omega will become what? 2 pi divided by t equal to A into g into rho by m. Now what we are getting here, time period, if we, they see all the other are constants, so time period will become inversely proportional to 1 by rho. Okay, so time period will be inversely proportional to 1 upon root of density of the liquid. In first case they are saying time period is t. So first case, for first case I will write t is equal to, okay, I am taking all these constants, like we can take this constants k upon root of density 1. Now second case, how much is the time period? 2t for the density rho 2. So divided by 2t, all the constants, these all constants, I am again considering k divided by rho 2. So this will become, now solving here, this will become 1 by 2 is equal to under root rho 2 divided by under root rho 1. Okay, that is what you are getting. What we have to find here? Rho 2 divided by rho 1. So rho 2 divided by rho 1 will become what? If I square on both sides, rho 2 divided by rho 1 will become 1 by 4. Okay, rho 2 divided by rho 1 will become 1 by 4. Let's check it quickly. 1 by 2, rho 2, rho 1. Yeah, absolutely. So answer will be option number 2. Okay, what is going to be our answer? 1 by 4, option number 2.